my minus 6. All right, next up we're going to backtrack here and go to 1.6, and this will be complex numbers. Complex numbers, also called imaginary numbers. I kind of like the name complex more because imaginary implies they don't really exist. They kind of do exist, just kind of in a different way than normal numbers. So an imaginary number is the solution to an equation that has no real solution, usually caused by taking the square root of a negative number. And so I is the most basic imaginary number. It is equal to the square root of -1, and thus I squared equals -1. Something we'll be talking a lot about is the complex conjugate. So the complex conjugate is, I call it the half opposite of a complex number. It helps remove the complex number from the denominator, so the complex conjugate of 8 plus bi is 8 minus bi. So you're always going to change the change the second number, keep the first number the same. All right, we're also going to talk really quick here about powers of I. So I have kind of my own technique here for powers of I. Let me zoom in a little bit. So there's two different processes, one for odd powers and one for even powers. But the key here is your answer is always going to be one of these four, so that makes it nice for multiple choice questions. And so for odd powers, I first kind of put an I off to the side. I usually put it in front. I don't know why I put it in back there. It doesn't really matter. And so actually, I'm going to write that over here. So I'm going to take an I out there, and I'm going to call this times I to the 22nd power. So obviously, if we multiply those back together, it would be the 23rd power. And then I'm going to write that as I times, and then I'm going to put I squared on the inside, and then we take whatever number is out here, which is now an even number, and we cut it in half. That's because of our power property here. 2 times 11 would give us back to that 22. So you can see if we put this all back together, it would take us back to the 23rd power. Now, the reason I like to do this is that now I know that I squared is -1, so I'm going to call that -1 to the 11th power. And then we know that a -1 to any odd power is negative, to any even power is positive. So this is I times -1, which is just going to turn into -I. So that's my answer for this one. All right, next up, number 2. So now we have an even power. So even power, it's one less step. We don't have to take that I to the outside. We're just going to put I squared inside parentheses, and we're just going to cut 56 in half here. So that would be 28. So now that's just -1 to the 28th power, which we said -1 to any even power is going to be 1. All right, next up here is 413th power. So this is an odd one. So we'll first start by taking I on the outside and turning this into the I to the 412th power, which then I will leave that I on the outside, and then we're going to put I squared on the inside, and then we're going to put 206 on the outside. So now we have I times -1 to the 206th. We know that -1 to any even power is just +1. So this is I times 1, so that'll be a positive I. Lastly here, number 4, it's an even one, so a couple less steps here. I'm just going to put I squared on the inside. 1, 2, 3, 4 divided by 2. I don't know what that is off the top of my head. So that'll be a 6. So then 34, so this will be a 1, 7, 617. Okay, so that'll be -1 to the power of 617, and to an odd power, that's going to stay at a -1. So there you see an example of each one of those. All right, next up here, we'll do some operations with complex numbers. So it's really just kind of all the same rules you would have if I was x. So you can kind of treat I like a variable. Technically, I is not a variable because it never changes, but for these ones, you can kind of treat it like that. The one difference is that I squared equals -1. So anytime we have an I squared, we should be switching it to -1. So number 5 here is just combine like terms. So we do 7, and then 3 plus 4 is 7, and then 5i minus 2i would be plus 3i. One more thing here, it does say put your answer in the form of a plus bi, so they just want the complex number out back. All right, next one here is subtracting. So for this one, we're going to just distribute the negative first, and then it turns into just combining like terms. So just make sure you switch the signs in there. Combine like terms here, so I have -1 for the real part, and then 6i for the imaginary part. And then number 7, this one is actually a multiplying, so this one would be a FOIL. So I'll do first times first is 12, outer times outer is negative 6i, inner times inner is a positive 20i, and then last times last is a negative 10i squared. So now I would combine like terms, but before I do, I always like to take care of the I squared. So this is really negative 10 times negative 1. So this is really saying plus 10. There's kind of a shortcut for that. Anytime you have an I squared, it goes away, but whatever it's attached to switches signs. All right, so now I'll combine like terms for my final answer. So I got 22 for the real part, the 12 and the 10, and then 14i for the imaginary part. All right, number 8, some more distribute and combine like terms. Really important that we remember that when we distribute the negative, it's now addition. Some people turn it into multiplication, which is not correct. So we have negative 6 plus 6i for that one. All right, another FOIL here. So we'll do first times first is 5, 5i, negative 3i, and then negative 3i squared. And so when I come, or actually, I'm going to do this one. So that'll turn into negative 3 times negative 1, which would be plus 3. So that'll be 8 plus 2i. All right, and then one more FOIL here. So I have 2/3 times 6. Now, I think of this more, or actually we can show our work here. 2/3 times 6/1. That'll turn into a 2, so 2 times top would be 4. All right, outer times outer, so 2/3 times times 15/1. That would turn into a 5 on top, so that would be negative 10i. Inner times inner is a negative 12i, and then last times last would be positive 30i squared. So that positive 30i squared would really be 30 times negative 1, which would be a negative 30. So 4 minus 30 is negative 26, and then negative 10 minus 12 is negative 22i. All right, next up here, we got some i's in the denominator, which we don't want. So anytime we have this, we kind of have two different strategies. So it says if there is just a pure imaginary number in the denominator, multiply the top and the bottom by I only. So that's what's going on here on number 12. So I'm just going to multiply by I. You could multiply by 3i or negative 3i is what a lot of people do. It's going to make more work for you later. So that's why I just say use I. So yeah, I'm going to do that, okay? So then this is going to require me to distribute up top. So I'm going to have 6i minus 7i squared. And then on bottom I have 3i squared. So then I'm going to remember that I squared is negative 1. And so the I squareds go away, but like I said, they change the sign of whatever they're attached to. So that negative 7i squared is going to become a positive 7. I'm going to go ahead and move that up front. And then on bottom here, this is going to turn into a negative 3. So the negative 7i squared becomes a positive 7. The 3i squared becomes a negative 3. Lastly, we want to put our answer in the form of a plus bi. So what we do here is we divide both of these by negative 3. So technically right now it's not in the form a plus bi. It's a plus bi over something else. But if I do this now, I have negative 7/3 minus 2i. You can see that the 7 doesn't divide by 3, so I just leave that as a fraction. 6 does, so I have that as an integer. Okay, next up here, number 13. So now, instead of a simple complex number on bottom, we have instead of a simple imaginary number on bottom, we have the full complex number. So for this one, I need to multiply by the conjugate of the denominator. So on the denominator here, I'm going to multiply by 1 minus 4i. So we don't change that first term. Even if the first term was negative, I would keep it as such. We change the second term. Now we have to multiply the top by the same thing. All right. Now on top, I need to do a full FOIL, but the denominator, I can actually do a FL, because these are conjugates. I can just do a FL here, whereas this one requires the full FOIL, because those are not conjugates. So the bottom, the FL, it would be 1 times 1 would be 1. 4i times negative 4i would be negative 16i squared. On top, I need my full FOIL here, so I got 3, negative 12i, positive 2i, and then negative 8i squared. All right, I'm going to get rid of all my I squareds. So this one would be 3. I'll go ahead and combine these to negative 10i plus 8 over 1 plus 16. Remember those I squareds go away, but they change the sign of whatever they're attached to. And then I'll combine like terms, so I get 11 minus 10i over 17. And then lastly, I need to separate this into two fractions here. So we'll do that. So we get 11 over 17 minus 10 over 17i. You could call that 10i over 17, but technically I would say this is better in the form. So a is 11 over 17, and then b is negative 10 over 17 times I, to have it in that a plus bi form. The very important thing is that the I does not go down in the denominator. All right, next up, number 14. So for this one, we have the just imaginary number in the bottom. So I'm going to go ahead and just multiply by I. Top and bottom there. So then on bottom, I got 4i squared. On top, I have 7i plus 3i squared. So that's going to become negative 3 plus 7i all over negative 4. We'll divide each of these here. So negative 3 divided by negative 4 would just be 3 over 4. And then minus 7 over 4i. All right, and then number 15. I'm going to multiply this by the conjugate here, 3 minus 4i. So on bottom, I can just do a fl. So for conjugates, we get 9 minus 16i squared. On top, we need the full FOIL, and so I'll do that up here, actually. So I got 15, and then I get negative 20i, I get negative 3i, and I get positive 4i squared. So I'm going to go ahead and call this 15 minus 23i, and then I'm going to call that minus 4. I know that on the denominator here, the negative 16i squared is really plus 16. I'm going to switch that as well. So on the top, I got 11 minus 23i over 25. I'll just divide that up, split it up here. So 11 over 25 minus 23 over 25i. All right, next up here, we will solve some quadratics. So this is why we do this, is so we can use these for quadratics. So if we have no b value, we can always solve this with square roots. So I'm going to subtract the 16 over. We'll take a square root on both sides. Anytime that you have a negative inside of a square root, well, first of all, anytime we create a square root, we need a plus or minus in front. And I always say pull an I out front, and then that negative 16 turns into a positive 16. So now I would just think about how would I do this with a positive 16 inside of a radical? Well, I would do the square root of 16 is just 4. So I'm going to call this x equals plus or minus 4i now. So if it was x squared equals 16, I would get plus or minus 4. Now if it's negative 16, I would get plus or minus 4i. For number 17 here, this one, you could try to factor it, thinking of two numbers that multiply to 5 and add to 4. There are two such numbers. If you're thinking 4 and 1, that's kind of backwards. That would multiply to 4 and add to 5. So this one doesn't work, so we're going to have to use quadratic formula with a equals 1, b equals 4, and c equals 5. So quadratic formula, we get x equals negative b. Plus or minus the square root of b squared, which would be 16 minus 4 times 1 times 5, all over 2 times a. So then that would be negative 4 plus or minus the square root of, this would be 16 minus 20, so that sounds like negative 4 over 2. So now using that technique here, when I have the negative inside, I would just pull an I outside and switch that to positive. We're not allowed to reduce the quadratic formula yet because we'd have to do it with a number in front of the radical. We don't have one. You're not allowed to go inside the radical there. But I know that the square root of 4 is 2. So I would switch this to -4 plus or minus 2i over 2. And then I see that we can reduce all of these together. So I'm going to do those two and those two. So that's going to give me my final answer here of -2 plus or minus I. All right, next up, number 18. So I'm going to, we don't have a b value here, so I don't need to use quadratic formula. Just going to move that over and then square root. So x equals plus or minus I times the square root of 20. And I don't know, the square root of 20 is not an integer here, so I'm going to break this down here and do like a factor tree. I'm always looking for twins here, so we have twin 2's, so they get to go outside. So I get 2i times the square root of 5. So once again, if x squared minus 20 equaled 0, I would say it's plus or minus 2 rad 5. But if it's plus 20, it'll be 2i rad, plus or minus 2i rad 5. All right, lastly here, we got 2x. I got to get one side to 0, so I'm going to subtract that 2x over. We could try to factor it thinking of two numbers that multiply to 6 and adding the -2, but they don't exist. So I'm going to do quadratic formula then. So -b, so it's going to be a positive 2 here since b is -2. The square root of b squared would be 4 here, minus 4 times a is 2 times c is 3, all over 2a. So we get 2 plus or minus the square root of, let's see, what is this? 4 minus 24, is that? Yep, it is. 4 minus 24 would be -20 again, over 4. Now, I actually already broke down radical -20 over here, so I'm actually going to copy my work, and I know that that's going to turn into 2i rad 5. It already has the plus or minus in front from the quadratic formula. And so I'm going to split this up into a plus bi form, so I'm going to divide both of those by 4. Neither fully divides by 4, but they both partially do. So I'm going to say this is 1/2 plus or minus let's see, that would be 1/2 rad 5 times I. And usually how they're going to write that is they would call that 1/2 plus or minus rad 5 over 2I. The 1/2 times rad 5 over 1 is how I got that rad 5 over 2. So they're usually going to multiply that radical up top and then put the I out off to the right of that. So that's how I would write my answer in the a plus bi form.